Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. So today we are going to discuss an important topic in graph theory, which is Euler graph. Right. It is also written here Euler digraph because it is a directional graph that we are going to deal with today. So let's first read the question. So show that the following is an Euler digraph. Determine the total number of Euler lines using formal method. Write one of them. So in the question we are given two things. First, this is a Euler digraph, means there will be a Euler line in this directed graph. Next, we need to determine the total number of Eulerian lines, and the last one is we have to draw one of them. So first we need to understand that what is a Euler digraph. So a Euler digraph is a directed graph which contains a Euler line. Euler line is a sequence of vertices and edges in which all the edges are contained in that particular path and no edge is crossed twice. So one of them is like we have discussed in a previous video of Sappheiros. You can check that out. I'll link that in the I button here. Let's move ahead. So here is the question that we are given. So if we look into it, there are directions for each of the edges, and if we see, we can have a Eulerian line in that. So if we go from V1, so let's say we have this particular edge first, right? Then we have 2, then we have 3, then we have 4, then we have 6, this will be 7, basically 5, then 6, and then 7. You see, we were able to traverse the entire graph without repeating any edge. So this is a Euler line. Similarly, what we need to do is basically determine the total number of Euler lines. So for that we have a formula which is sigma times of d plus of vi minus 1 factorial. So this d plus of vi is basically the out degree of a vertex. So we need to calculate the out degree of all the vertices in the graph. So here in this particular equation, sigma is basically the number of arborescences which we have discussed. So that is something that I'll leave you guys with the previous video so that you can come back here and check it out and calculate yourself. But this formula is something that we will be needing in order to calculate the number of Euler lines. Similarly, so the formal method that we have mentioned previously is like this. We first need to identify the outgoing edges, traverse them first, as in this case I first dealt with the outgoing edges. You see, we are coming out from this particular starting point, right? So this is basically we are going outwards away from the starting point. So that is what is written here. Identify the outgoing edges, traverse them first. So first we will traverse the outgoing edges, then we will traverse the remaining edges. Like when I was here, I could have moved backwards, but I chose to move away from the origin, that is the starting point, and then I came back down in this edge, and then I went back to the original starting point. So that is what written here. We need to then traverse the remaining edges. Now let's take this particular graph as example. So in there, let's take this edge 1, then I take this particular edge. Okay, so it is 2, then I have this one 3, then I have this one 4, then 5, then 6, and lastly 7. So I changed the number in which we are traveling. Still it is a Euler line, and the arrow direction is not what I have given. It was already written in the question, so I just copy pasted that. So if we traverse the graph in this manner, then also we are able to get a Euler line. So in this way there will be many Euler lines, and the number can be calculated using the formula I just mentioned above. So if let's check for vertex 1, so let's say we want to calculate the number of Euler lines that are passing from vertex V1. So for that, what we can do is basically the out degree of vertex V1. If we see that the out degree here is 1 for this particular, and for this particular it will be 1 as well. So both it is 2, right? So 2 minus 1 factorial, which is 1. So there is only one Euler line which passes from V1. So that's been it. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.